Okay, so moving on to section 2 of chapter 12, we're looking at our sine, cosine, and tangent ratios. So these are the main three, your basic three ratios that you're going to be dealing with. Um, the reciprocals of these you won't really be seeing in this class. You'd be seeing it in Algebra 2 is kind of the introduction to it. So sine, cosine, and tangent. So if we have our sine, cosine, tangent is basically broken down to this. You have your sine, cosine, tangent are all ratios. They're all fractions. Okay, so they're all fractions off of a right triangle, depending on which angle we're talking about. So let's say we're talking about this angle here, which I'm going to denote as theta. The opposite leg is going to be this one. Okay, the one across from it that is not touching it. Okay, the hypotenuse is always the longest side, so it's the one across from the right angle. And the last one is your adjacent side, which your adjacent side is always the one that's touching that angle. Okay, so that's the adjacent. So when you have sine, sine is the opposite leg, the length of it, divided by the hypotenuse. The cosine is the adjacent leg divided by the hypotenuse. And the tangent is the opposite leg divided by the adjacent leg. So you see tangent doesn't deal with the hypotenuse at all. Okay. Now, if you're dealing with the other angle, so the angle across the way, what ends up happening is that the adjacent and the opposite sides switch. So if you're dealing with that top angle, the opposite side is now at the bottom, and the adjacent side is the one going up and down. Okay, so you just have to watch out for which angle you're dealing with, because the opposite and the adjacent can switch depending on its location. Okay, it's not always the opposite. It's not always the adjacent side is the same one. Okay, so these, to help you try to remember it, there's a little thing. Well, it's a short way of saying it is SOHCAHTOA. So if you ever hear me talk about SOHCAHTOA, it's the trig functions: sine, cosine, tangent. So it's sine is equal to the opposite over the hypotenuse, SOH. Okay, cosine is equal to adjacent over hypotenuse, and tangent is equal to the opposite over adjacent. Now, there's another way of helping you remember this. Instead of trying to think of SOHCAHTOA and how to spell it, SOHCAHTOA, another way of remembering the letters for it is by doing this one. Is for our sine opposite adjacent is some old hippie, okay, caught another hippie tripping on acid. Okay, so again, some old hippie caught another hippie tripping on acid. And that's just another way to help you remember the letters. So again, it's the first letter of each word to help you remember what it was. Okay, but it stands for sine opposite. Sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. But again, SOHCAHTOA, some old hippie caught another hippie tripping on acid. Either one of those is fine. So let's say we have this triangle right here, this right triangle, sides 3, 4, and 5. The hypotenuse is obviously the 5 because it's the biggest side. Okay, so if we want to find the sine of P, so side or angle P, okay, if I want to find the sine of it, if you remember sine is some old hippie, OH, opposite hypotenuse. What's the opposite side of P? Opposite side of P is 3, hypotenuse is 5. So that means that your answer would be 3 over 5. Okay, so it'd be 3 over 5. Okay, so now what I want you to do is I want you to take a second and I want you to find the rest of these trig functions. Find the cosine, find the tangent, the sine, cosine, and the tangent of Q also. So you see with these bottom three, you're taking it based on this angle, not P. Okay, so they're going to be slightly different answers. Okay, you can keep them as fractions. You do not have to put them as decimals. You don't have to reduce them. None of them will be able to reduce, but you can just keep them as fractions. They're ratios. You don't need the decimals for them, so keep them as fractions. So take a second and answer all these. All right, so cosine of p ends up being the adjacent over the hypotenuse, which ends up being 4 over 5. Okay. Tangent of p ends up being the opposite over the adjacent, so that would be 3 over 4. Sine of q ends up being, taking it based on this one, again it's opposite over the hypotenuse, so now the opposite of q is 4, so it'd be 4 over 5. And the cosine of q ends up being the adjacent 3 over 5. So as you notice with these, what we have is that we have kind of a connection, okay, between them. You see how sine of p and cosine of q are the exact same, and cosine p and sine of q are the exact same. Okay, so since they are the same, there is a relationship there, and when you go into more trig, you can see that relationship coming up more and being more helpful. Okay, so that's the end of this one. The last one is basically just the reciprocal of p, which the answer is right. It's 4 over 3. Okay, all right, that's the end of this section.